Today, we're going to be focusing on the kind of AI that is being used in business today and how you can use it. So I'm gonna go through the 3 stages of AI in this talk, but we're gonna be really focused on this first stage of AI, which I like to call weak AI or artificial narrow intelligence. So when it comes to artificial narrow intelligence, you have an AI algorithm or model that you can teach to do one thing. And so, in Ray's talk, he mentioned how incredible it was that you have AlphaGo Zero, the DeepMind program that can beat the best human at Go. And that program is amazing, but AlphaZero can't also play chess. You could potentially teach that algorithm to play chess as well, but you would need to train it on new data. So when you think about weak AI or narrow artificial intelligence, you want to think about an AI model that can do one thing. And it might be able to do that thing much better, much faster than any human, but learning that one thing is not going to make the model better at doing additional tasks. And this is very different from a human. So if you teach a child how to play checkers, that makes it easier for the child to then learn chess, which in turn makes it easier for the child to learn Go, which is an even harder game. So with weak AI, again, you're thinking about an AI that can do a narrow task. And the first stage of AI, when we think about applying it to business, I call it the incorporation stage. And it's the incorporation stage because you're going to find these narrow AIs used in business within our existing businesses and processes. So this AI used in this stage, weak AI, might be used to help doctors do their jobs better, or it might be used to help architects, or, for example, to help truck drivers. So we learn a lot and read a lot about self-driving cars in the news. But already on the roads, there are actually companies that are deploying devices to basically be following truck drivers as they drive and recognizing when they are, for example, distracted and alerting them. So these devices that are using AI to monitor truck drivers and to result in fewer collisions on the road, it's a very narrow application of the AI. The AI is not yet replacing the human. And that's our first stage of AI. And one way to think about how powerful this stage of AI is, even though it is just incorporation and just the first stage, is to think about comparing a horse and a car. So there are a lot of ways in which horses are actually superior to cars. So a horse can end up recognizing a route by itself. If you keep a bunch of horses and you treat them well and they're in a particular place and you've got male and female horses, you might end up with some self-replicating horses. You're going to have some new ones. Whereas if you keep a bunch of cars in your garage, you're not going to end up with any extra cars, right? And that said, to take a car from one point to another, if you've got a good road, is much more powerful than driving a horse, which is why our human society today has changed a lot from the time when we all rode horses. So, but cars, again, they're good at getting from point A to point B. They can't replace every bit of a horse, but they still have replaced the key way that humans would use horses. So I want to compare AI and what AI can do to the kinds of computers and kinds of computer programs we're all familiar with, whether or not we're using AI today. So I call what we have been doing up until now pre-AI software 1.0. And with software 1.0, what you do is you take a hard problem like getting to the moon, and you break that problem down into small problems, and you create algorithms to solve those problems, and then you invest a lot in your systems architecture to take those problems and weave them together in a full-fledged solution. And software 1.0 is pretty incredible. Not only has it gotten us to the moon, but we have automated many systems and processes, and we do a whole lot online and with computers that do not rely on AI. And we do it with actually much less computational power. So we got from the Earth to the moon with computers that were less powerful than the computer we all have in our iPhone. And the computers that we have in our iPhone, they're very powerful, but they're still not powerful enough to run cutting edge AI. So AI, narrow AI, I call software 2.0. And for software 2.0, there's 3 key inputs. There's data, computational power, and your algorithms. And a lot of people spend a lot of time focusing on the algorithms or the models. And they want to find some way of creating a new, better model. But when it comes to bringing your AI into business, it's not actually about your algorithm. So Google makes available some of the most powerful algorithms around today for free on TensorFlow Zoo. And so if you want the state-of-the-art model, you can get that for free. But what you can't get for free is data, particularly data where you've trained the data to support the machine in being able to understand and interpret that data. And then the other piece that's really key for a successful machine learning application is the computational power. Because the methods that are used in software 2.0 in weak AI use enormous amounts of computational power. And let me explain why that is. So our innovation when it comes to software 2.0 is the ability to have a deep neural network. You have inputs, those are the X's on the slide, and then you have your neural network. And you can see you have these various layers, and you ultimately get to the output. And in software 1.0, if you were, for example, going to have a software 1.0 program that would recognize features in a sonogram and be able to support a doctor in reading the sonogram, you would have to take that problem of how do you find the features that are relevant, that are what a doctor would find, and you would decode that into lots of little pieces. And then you would find small algorithms to solve those different pieces and take your systems architecture to build up a solution. And the solution would be, it would take less computational power, and you wouldn't need the training data the way you need with AI. But this kind of software 1.0, it's going to be brittle. And it could potentially help a doctor, but it's not going to be nearly as dynamic as software 2.0 or AI. So with software 2.0, what you have is instead of basically as humans figuring out what are the features that are important for the computer and then encoding them into algorithms and building that systems architecture, you label the relevant features. So you can see on the slide the various color blocks. Those color blocks that are there on the slide, that's the image being labeled. And so those blocks are going to be recognized by the computer. And humans are actually going to be labeling the data. So you might take a radiologist and have them start labeling slides. And you're going to then feed those labeled slides into your neural network, and you're going to train your neural network. And then basically what you do is you take new data and you test it and you see, okay, we put in these new inputs, what does the neural network come out with? And that's going to be when you're deploying your model. And so the key part here is the labeled training data. I like to call labeled training data the new gold, because getting access to that data is expensive and hard. This is part of why we see some incredible advances in AI taking place not in startups, but in large companies, where they actually have access to proprietary data sets. And it's not just enough to just have the data. You have to find a way to structure the data. So if you think about taking information and putting it into Excel, how many of you here use Excel? Everybody's used Excel. So you take data, you take information, when you put it into Excel, all of a sudden you can run operations on that data. Excel structures your data. You now have a way to interpret and interact with the data in a new way that makes it very easy to run programs. And similarly, when it comes to our proprietary data sets in industry, we have to label that data so that our machine learning algorithms can recognize the relevant features of the data and come out with the results that we can deploy in production. And so now we have had in just the past 18 to 24 months a pretty incredible development in access to tools to help us to train data without needing coding. And so here you can actually see what it looks like to train data. So you've got some geospatial imagery data, and that data is being labeled. And then you've got solar panels. These are defects on solar panels that are being labeled. And you can have humans do that labeling from anywhere in the world, and they don't need to know how to code. So if we think again about software 1.0 versus software 2.0, in software 1.0, you need people who know how to code to figure out how to take the relevant features of the data and build out your system's architecture to come up with a solution to your problem. But with AI, what you do today is you can use these tools to label data. You label lots and lots of data. You feed that into the models, and then your AI models can start to provide better results on new data without you even necessarily fully understanding why and how they're doing that. So I'm going to talk to you a bit more about computer vision in particular. So computer vision is teaching machines how to see. And when it comes to software 2.0 or AI, it's not just computer vision. We can also create AI that can hear. People are working on creating AI that can speak. Any cognitive task that a human can do, we can use these AI methods to teach AI how to do those tasks. But for computer vision, what we're doing in particular is we're teaching machines how to see. So one example of very advanced and powerful computer vision is Facebook's facial recognition. And so Facebook's facial recognition has gotten so powerful because part of the Facebook business model is we have all trained the Facebook data. So when we upload photos to Facebook or Instagram and we tag those photos, we're actually teaching Facebook's AI algorithms how to see. And with computer vision, what's interesting is the features that matter for recognizing a face are very different when it comes to computer vision that works than you might think as a human. So it's not about eye color. It's not what we humans might point out, but it's actually about the distance of the various facial features. So you can kind of see these dots on this image. These are the aspects of facial features that are extremely relevant for facial recognition programs. And the difference between a simple neural network and a deep learning neural network is that with a deep learning neural network, we have a nested set of layers of these neural network classification structures that start to recognize different aspects of the face. So you might start out, you can see feeding lots and lots of input, lots and lots of label data into the neural network. And the layers that are the furthest out, they start to recognize the most general features. And then moving out deeper and deeper in the neural network starts to be able to pick out faces and eventually an individual face. And think about how when you look at this nested layer of the neural networks and the deep learning, that actually is very computationally expensive to run. And that's part of why computational power is so important when it comes to software 2.0. And so Ray actually talked with you folks about this morning, but again, it can't be underemphasized. The fact that computational power is doubling every 3 to 5 months is incredible. And it means that these deep learning neural networks that are very complex and very computationally expensive to run in the sense that they take enormous amounts of computational power, that computational power is exponentially more available every 3 to 5 months. And not only that, but it is exponentially less expensive to deploy that computational power. So the cost of computing is decreasing exponentially. And so when you bring together these 2 points, the fact that this computational power is exponentially more available every 3 to 5 months, and you combine that with the fact that the cost of computation is decreasing exponentially, it means that we can do incredible things. So Facebook can recognize human faces. Aquabite is a company, it's a startup that can recognize fish faces. So it's funny, but it's true. Individual fish have difference in their faces. And we could never do that as humans, and we could actually never do that in software 1.0. Because in software 1.0, we as humans would have to be able to recognize and point out the individual features of the fish for the program to start seeing. But using deep learning, we can start training models to do things that we never could do before. And Aquabite is deploying this technology to support sustainable fish farming. And another way that I'm seeing AI being used in enterprise today that's very exciting is in the insurance industry. So when it comes to insurance, some of the most expensive parts of running the business are assessing claims, determining whether there's been fraud in a claim, determining the extent of a claim. And insurance companies today have access to incredible proprietary data on images of insurance damage, and they're actually working on developing models to help them and to help the human people that work at those companies to do a better job and to increase their bottom lines. And so with that example of insurance, this is an AI-enabled business blueprint. For those of you who are not yet doing AI, this is how you want to think about starting an AI program. You need your data, your raw data. And I've been talking about computer vision, but it can be text, it can be audio, or video or images. And you need to train that data. So you need to take the intelligence that's unique to your organization, whether you're an editor of a magazine or you've got your particular formula as an insurance company, and you train the data according to what you know. So one mistake that people make in AI is they try to outsource everything. But just as you wouldn't outsource your sales team, you might get tools like Salesforce to help your sales team, but you still need your internal sales team that knows your product. You can't outsource all your AI. So you need tools to help you and to help you build better AI, but you don't want to outsource the whole thing because your AI is going to be very specific to your organization. And then once you've got your trained AI, you take your humans and your models, your humans and your model decisions, and you actually can start building your AI models, and then you can take new data and put them through the model. And then the results of the model can get sent to the human trainers. And so your model is going to get better and better over time because it's this iterative process that continues to improve. And that's actually also part of why McKinsey's done a study that shows that the early adopters of AI are going to get outsized gains when it comes to taking advantage of AI, because this recursive, iterative effect of building a better model, it's going to accrue fastest to the people who start soonest. So the sooner you can start building your AI, the better. And so this is what you do to make AI your competitive advantage. For each of you in the room, you want to define a narrow problem with high ROI in your business. So for example, in the insurance case, that might be figuring out if a claim is fraudulent or not. Then you collect the relevant data. And if you might already be sitting on a treasure trove of that data, but this is the hard part. You've got to label your data. You've got to structure that data in a way that your AI can recognize. And then you train your machine learning model to solve the problem. And that's actually the easy part. Some people are intimidated and they think, hey, I can't hire $1 million a year AI researcher. But you don't actually need much of that because the models are free. Google has made them available to everyone. And then you iterate. So you've got your model, you start running that model on new data, you improve your models, and you start bringing your models into production. And when you bring your model into production, you use it to help humans make decisions. So you still keep your human in the loop. You're human in the loop. And that's what you do with respect to narrow AI. Now, the world is also changing very quickly, and we are far away from general AI or strong AI. With general AI, when you would teach the AI to play Go, it would get better at other things as well. So you'd have one AI algorithm or model that could be better than a human in many areas. And we're not there yet. We're a ways away from there. But when we do get there, it's going to change everything. Because at that point, not only do you have AI that can do one thing, you have AI that can do everything. And so for those of you who like Star Trek Data or in Star Trek The Next Generation or Star Trek Voyager, those are examples of general AI, where you have an AI that can do a whole lot and that really changes how our world operates. We're still a ways away, but you want to be aware. And then stage 3 is the singularity. So Ray Kurzweil, who I'm really honored to be here on the same stage as him, he said, look, when you get general AI that can create AI that's even more intelligent than it, who knows what will happen? Our human intelligence can't even conceive of what will happen at that time. So that's true. I call this stage the transmutation stage, because transmutation is the word for, in a way that no one understands, transforming lead into gold, which the ancient alchemists tried to do. So in the transmutation stage, it's very difficult for us to predict what will happen. And it's likely that stage 2 and stage 3 will come very close together, because general AI will be better than humans, not just at playing Go, and not just at singing, and not just at making art, but also at creating AI. And so we do want to be aware that this is where the future is going, but for now, we're living in a world of narrow AI. And so my question for each of you is to really think about what problem you can solve in your business, in your work, using AI today. And so with that, thank you. My email's here if you have any questions or you're interested in understanding how your organization can actually put on a pilot project. Please email me. I work with companies around the world on that every day. So thank you.